We have our last project. We welcome the presenter from Sri Lanka, Ravindu Subashinghe, who is here to present distinct visual features of Sinhala digital fonts, which contribute to similar letter misidentification. We have extremely fond associations. He's from the University of Moratuwa, Sri Lanka. Ravindu is a student of University of Moratuwa, and we have very, very special association with Sri Lanka and the University of Moratuwa because our 2017 Typo Day was hosted and held at University of Moratuwa. It was a memorable event, and I still remember the Grandmaster who was feted with the Lifetime Achievement Award. So also some of the key speakers from Sri Lanka itself, and all the hospitality and everything. So welcome on board, Ravindu. Please come in. Please make your presentation. We look forward to hearing about your project.
I'll be talking about distinct visual features of Sinhala digital fonts, which contribute to similar letter misidentification. So it's a mouthful, I know, but I'll be trying to break it down and explain what it means and what are these particular terms. So it's actually part of my final thesis for my master's project. So I'll be explaining about on letter legibility, first of all. Then I'll be talking about distinct visual features. What are those and how do we define them? So actually, and the differences in the anatomy of Sinhala letters from Latin letters. So this research is basically based on Sinhala letters and how they differ from Latin letters. So, and what is similar letter misidentification and the relationship between similar letter misidentification and legibility. So these are the key points that I'll be talking about. So why did I do this research? So what was my approach? So in this information age, there's a lot of information going on, a lot of ways to access information, a lot of interfaces. So using these interfaces by children has been increased. So like even small kids have their iPads and they browse through YouTube. They have the necessary ability to browse through YouTube and browse those application schemes. So in order to facilitate this transition, a legible typeface, even by small children, are necessary. So it's an absolute necessary. So that was my approach for this particular project. And so what is legibility, first of all? So it can be defined as the clarity of letters while influenced by typeface familiarity. So there are two key terms that you have to understand here. It's the clarity of letters and typeface familiarity. So typeface familiarity is the similarity between the same features of a typeface. So for an example, if I take letter in English, letter L and letter I, they have a typeface familiarity. Letter A and O, they have typeface familiarity. So in this definition, so legibility is a heavily contextual subject. So the definition changes according to the context. So for an example, legibility of a road sign is totally different from legibility of an Apple Watch interface. So those are two separate ends of interface legibilities. So legibility can be a contextual subject. So this typeface familiarity consists of two main factors. Typeface familiarity consists of two main factors, the subjective and the objective. So the subjective is the anatomy of the letter and the objective is the surface of the information. So for an example, objective of can be a newspaper or objective can be a digital screen like a mobile or laptop. So legibility, so I explained before, there are different factors affecting the legibility. One of the factors is a similar letter misidentification. So this similar letter misidentification happens when the characters of a letter, the shapes of the letter becomes kind of similar. So here are some commonly misidentified characters in Latin. So for H and B, E for O and C, N and U, I and 1, A and S. So these are some characters which are commonly misidentified. So in order to identify single letter anatomy, single letter legibility, identifying single letter anatomy is very important. So there's a problem with identify single letters because that the identification methods are totally different because anatomically single letters are different from Latin letters. So even the baselines, the construction methods, they can be totally different. So for this particular purpose, it comes to factor called distinct visual features. So what are these distinct visual features? Distinct visual features are the most basic stroke or the skeletal structure of a letter, which can be called also as the stroke primitive. For in this example, this is a letter per, and at the bottom you can see the letter per in 6 different fonts, and at the top you can see the distinct visual features of that particular letter. So if you take any font, the letter per in any font, its distinct visual features remain the same. For an example, in this case, the I, I2, I1, and the base stroke. So those are the distinct visual features of letter per. So distinct visual features and the anatomical structure can be different. So the font has the anatomical structure, but the anatomical structure can be different from font to font. So here is an example. These are 4 separate fonts of the same letter. And I have analyzed that, for an example, I've shown the I, the distinct visual feature called the I. And you can see how the I varies according to different fonts. So these are all some of the distinct visual features. They are on fonts. So distinct visual features are also can be called atomic features. So anatomy and atomic features. So atomic means the most basic structure. That's also called the distinct visual feature. So I did a visual analysis for this research. So I picked 12 fonts from monolinear to modulated, both print and digital. So I analyzed these fonts with their anatomical structure and their distinct visual feature, also called the atomic property. So these are those analyses. So all 12 fonts, I have analyzed all the letters and I've recorded them. So how the distinct visual feature remain the same, but the anatomical property changes on each of these letters. So you can see here, as a previous one also, atomic distinct visual feature, different distinct visual features, even through different letter forms or different fonts. Their distinct visual feature remains the same, but their anatomical structure differs. So next one is analyzing these differences, how the anatomical structure differs from the distinct visual features, and how can we use these differences or these variations by analyzing them. How can we use them to our researchers, and how do we untangle this relationship between distinct visual feature and legibility of the structure of a letter. So these are some analysis done. So the red line here is a most basic letter with only distinct visual features, and the outlined gray line is the anatomical structure. So these are the separate fonts and the anatomical structures compared with the distinct visual features. So in order to compare this legibility issue and distinct visual feature, we have to test a font. So we can't do that without taking one single. We can't do that with all the fonts. So we have to select one single font and analyze it at that particular font for these kind of changes. So what I did was I did a legibility research with 4 particular fonts. These are Bhashita Complex, Noto Sans Sinhala, Iskolapota, and Nirmala UI. So these 4 fonts I chose because they have some particular properties that I wanted. So they are all multi-platform and primary usage, they are used as body fonts, and they have very high anatomical diversities among the fonts, and they are also Unicode. So I want digital fonts for this, since I'm focusing on digital interfaces. And also when using these, I wanted to clarify another problem. That's the X height, or in Sinhala we using the letter per, the per height. So even though the point sizes of these letters remain the same, their heights can be different. But since we are analyzing the anatomy of a letter, I've normalized these heights. So I've used the same per height and different point sizes for these analysis. So these are the reading samples that I prepared for those reading experiments. So they have different point sizes, but each and every letter have the same per height. So I finished my experiment. The results were recorded, and you can see that there are 4 fonts have different reading speeds. So, for example, Noto Sans has the lowest reading speed, and Escolapota has the highest reading speed. So, which means Noto Sans was the most legible font, and Escolapota was the least legible font. Since it took more time to be read. So, next what I did was I took that Noto Sans singular font, so the most legible one, and I took it as a base font for my experiments. So this next thing was doing the superimposition. So superimposition is a basically method of superimposing letters, keep putting letters one top of another and examining the areas which are overlapping and which are going out of bounds. So what I did was I superimposed these particular letters and visually analyzed their anatomy, and which I identified which parts has a common area and which parts fall out of the common area. So these are the different fonts I placed on one top of each other, superimposed, and comparison with the distinct visual features. So this is also another method of superimposition. So the main reason for this is identifying what areas deviate the most. So by identifying that, we can see how the differences of the letters and how their differences match with the distinct visual feature. So it could be seen that these highly deviating areas are the places that these letters change their anatomy significantly. For an example, hook, the distinct visual feature called the hook at the letter M, and the distinct visual feature called the I at the letter V. So these are highly deviating areas. So so the assumption was these must be the characteristics that define these kind of particular fonts, and these characteristics must be the factor that govern the legibility of these fonts, since that's the main thing that defines and separates these fonts. So this is the separate fonts superimposed on each other, and this time I wanted to see the anatomically similar letters on the top of each other. So in order to understand similar letter misidentification, there was a selected pool of letters that are kind of anatomically similar, and I wanted to superimpose them on top of each other so to see the results. So this is another letter. You can see this is a really close call. So these are two totally different letters, ch and v. They have two different sounds, but their anatomy is rather similar, really similar. So this is another thing, another method of superimposition, understanding deviating areas. So I did this for all 4 fonts here. So these distinct visual features, superimposed anatomically similar letters, are then taken and analyzed. So I identified highly deviating areas. So after identified those highly deviating areas, the result were that I identified 15 letters that are most commonly misidentified in Sinhala language. So these 4 letters from Noto Sans Sinhala, I superimposed them and I took the results and I identified 15 letters separated into 5 different groups. So each group have a similar letter misidentification. Each group are anatomically similar and they commonly identified as one or the other. So these are the set of letters that I identified, 15 letters. So next is the most important one. So identifying what are those distinct visual features of Noto Sans Sinhala and how can we change these features to affect the legibility of individual letters. So if these features are the reason that these letters have a different legibility, then how changing these legibilities can affect, how changing these distinct visual features can affect the legibility of these particular letters. So what I did was I separated this into groups and I segregated them and I tried to analyze them. So using these high deviating areas as a reference, so Noto Sans Sinhala letters were analyzed. So these are the groups and how they were analyzed. You can see here, each group has a separate box and they are superimposed on top of each other. So after that superimposition, but when I take one particular segment from each group, their letter seems something like this. So what I identified was there are some places or areas that are highly deviating and some areas that are highly overlapping. So I wanted to change these features according to their method of overlapping or method of deviating. And I modified these letters to see how that legibility affects these fonts. In this stage, how legibility affect these particular letters. So what I did was I drew 3 variations of each font. So there are 15 fonts. I drew 3 variations of them from the base font. So one variation is a very low distorted variation and the medium distorted and very highly distorted variation. So these variations are done according to these overlapping and non-overlapping areas. So a total of 45 samples were created in this manner from distortion, and I've included, so this is the, for an example, this is one example. So curve to curve joint is the distinct visual feature. And what I did was increase the counter space. So after analyzing overlapping areas, I increased the counter space and I did 3 separate variations than the original letter. So low distortion, medium distortion, and high distortion. So you can see the counter space increases when it goes to very high distortions. This one is distinct visual features reducing the eye and the change is reducing the eye. So you can see it the high distortion, the eye is very small. This one is curve angular joint number 2. So the change is changing the nose lines. So this is the another distortion. So a total of 45 letters was created with this method. So including those distorted versions and the original versions, a total of 45 letters were created. And I want to test these legibilities of these particular letters, how the distortions worked out and how the distinct visual features changed those legibilities. So and also the medium distortions were not used, but because there was not much of a difference between low, very high and the medium distortion. So medium distortions were not used in this research since it didn't give any more legible results. So I did a small experiment. I displayed those fonts on a computer screen with the test to understand the legibility. So a total of 100 participants were selected for the experiment, and they were asked to identify the altered version or the original version on the screen, which is displayed with for a very small amount, a small time. So the letters are displayed from a custom-made animation. So and they were given to fill the form to identify that particular letter and fill it on the form. So this is the result that I identified. So in this short exposure test. So the x-axis is the number of letters. So letters 1 to 45, and how many of them were identified. So you can see there's a very drastic difference. So some letters are even reaching to really close to 100%, and some letters are at like 41, 42%. So after analyzing those results, these were the most recognized letters. So you can see these letters S, K, G, and N, they have very high recognizability. So as much as 97%. So you can see all of these are original letters. And mostly commonly misunderstood letters were these letters. Some are going down to like 42%. So these are letter B, H, Ch, and V. So you can see all the distorted letters, some of the distorted letters are here. So what I did was then compare them with other fonts that I chose in experiment 1. So this is the comparison. So this is the most legible letters compared with the most legible letters in the Iskolapatha font. So Notas and Sinhala was the font that I took for the experiment, and the Iskolapatha font was another font that I took. So this is another comparison. So this is another comparison of similar letter identification of another font, Iskolapatha and the Notas and Sinhala, how they change and how they interact with their distinct visual features. This is another one. So what I found from this, so the presenting methodology is specific to Sinhala scripts to analyze its legibility studies. So defining distinct visual features, I define distinct visual features that optimize legibility for small digital screens. And I also proved that legibility of a font is directly affected by anatomical changes done to their distinct visual features. And legibility of a Sinhala font can be improved by reducing similar letter misidentification. Similar letter misidentification means, in this case, misidentifying their distinct visual features. So identification of similar and also identification of similar letter sets in Sinhala which affect legibility. Similar letter misidentification in Sinhala font is caused by the lack of distinction between their distinct visual features, and legibility of a font can be improved by adjusting their distinct visual features of mostly commonly misidentified letters. So those are the conclusions and findings I found from these two particular experiments, and identifying their distinct visual features and how they interact with their legibility in particular instances. So I can, so what are the applications and future development for this? This research can be used for widening our understanding about Sinhala typography and methodological analysis. So there was no methodology analysis on to distinct visual features and legibility, specifically legibility in Sinhala fonts up to this date. And it can act as a baseline for contributing towards designing a Sinhala font, which is focused for legibility particularly. So this experiment can act as a base for legibility, and another font can be developed by using these particular theories and taking this data into consideration. And this legibility and accuracy becomes really important factor when it comes to designing for children. So anyone who is designing a font for children can take this data and base their researchers and base their designs and findings according to this. So that will be all. And thank you for listening. So that's all that I have.
Thank you, Ravindu, especially given the fact that you have managed to come for the presentation in spite of difficulties at your end. And we understand because we are in touch with your faculty members, Sumantri and others, and we know we have a fair idea of the difficulties that are, that you're all plagued with in your everyday lives. And I just wanted the audience to know that in spite of those, Ravindu has been able to come. He almost dropped off because of, all kinds of, typography difficulties. I mean, he simply, the logistical difficulties in the background. So we appreciate that. And I would now like to throw the floor open to the audience. You don't have to only ask questions. You can also make observations. We have, please go ahead. I would have Puvaya start with his question. I think it's for Ravindu. So please go ahead.
I had a question for you, Ravindu, but I think in your last slide, you kind of answered that, whether the methodology could be used for designing typefaces for children. That's a concern right now because of the new education policy, and that children, will be required to, learn in their own languages. So it's a very important aspect, and your methodology was very detailed and quite nicely explained, so that's, I think, a very good takeaway from your project. Okay, so from your project of analyzing this legibility and using it for design, I mean, what is your comment on it? How much did the legibility finally increase? Do you have those percentages? Before the changes, but after the changes?
Yeah, what I did was I wanted to confirm that my theories first. So I didn't go for a method of increasing legibility. What I wanted to confirm was whether these distinct visual features, changes to these distinct visual features affect the legibility. Okay. So further development can be made, like how can we change these particular distinct visual features on particular ways to increase or increase the legibilities in like minute amounts or really large amounts. And we can even create that totally different fonts using these theories with the perfect distinct visual features, which has the perfect legibility in Sinhala fonts. So I didn't go for like increment of kind of like that. That was not the approach. I wanted to understand how the changes to the distinct visual features affect the legibility.
Okay. Yeah.
So I don't have the data on that.
But to design the font, then you have to use it the other way around, right? Yeah.
Yeah.
Yeah. If you have to redesign the particular typeface for legibility, then you have to use that data and redo that, isn't it?
Yeah. So yeah, when designing a font, the methodologies can be like different according to particular origins, like for Latin and Sinhala and Devanagari Tamil. So they have different origins. But when considering that these distinct visual features, like the core base skeletal of the structure, how we can see that we can create the anatomy over that, like it's like a skeletal structure. We can do the flesh over it.
Right.
In the sketching part or the sketching stage, we can create the anatomy on that. So when creating that anatomy, we can have that these data and the researchers in mind, and we can create a more legible kind of structure that the anatomy can be based on.
Sure. Thanks so much. Just a comment on Lekha's project. It's very well done, and I think something like this will be quite inspirational for children, because you combine very good story with giving it a form through typeface, So for early learners, it's a good story, like in the first keynote Rupini was mentioning, right? They're using storytelling for children to remember the story, and they identify forms in it. And you've done it very nicely. You use storytelling, you use play. Okay.
Yes.
Yeah. And recognition of letter forms. Very nicely done project. Yeah.
And it can also be applied to other languages, right?
Right.
Yes. I can explore more, yeah.
Yeah, other languages, including Latin. Latin would be easier actually, because straight lines. There's one question here from Vrinda. She asks, how did you calculate the reading speed of fonts? Interesting data. And I guess it's addressed to Ravindu, right, Vrinda?
Yeah, for in this research, there are two particular experiments. So first one is a reading of a particular paragraph. So it's a whole paragraph. So what I did there was a reading legibility test by Larson. So it's a real life test to calculate the legibility. So I used that particular test and took the data. And in the second part, when there are single letters are involved, what I did was, it's a short exposure test. So this short exposure test was done by, it's a combination of two tests from Pike and Owing. So they have done this a similar test. So I took those tests, and it's a test to identify how quickly a person identified that particular letter in that context. So the letter is exposed for only 0.25 seconds for the reader. So, and at that small time, they have to identify the letter. So if they identify that letter as another one, that letter is a failure. So it must be identified as a particular specific letter. That helps us to understand that this phenomena of similar letter misidentification, because when someone is reading, they are reading not reading letter by letter. They are reading at the middle of the sentence and reading at a glance. So we have to consider that particular phenomena, and when we are doing this kind of research. So the letter is exposed for really a small time period, and like 0.25 seconds, and the reader is asked to identify that letter, and there's a sheet given to them, and they have to write that what they saw. So that's how I calculate the particular data.
Right. Thank you, Ravindu. There is also Nitin Daga who says, I like this way for survey. And then there are lots of congratulatory comments for Lekha. So Lekha, please go through the chat and you'll see all of those comments. If there are no more questions, we would end the session.
Thank you all the panel members for your wonderful presentation. I thank Dr. Ajanta Sen for chairing this session.